Welcome to another Anatomy whiteboard walkthrough. In this video, we will go through the specific branches you need to know from your celiac trunk that supply your foregut organs. This is technically the third video in a three-part series. The other videos are to get you ready for this one, so let's jump into the nitty-gritty specifics of the celiac trunk. Alright, so I'm going to keep this organ diagram here just for reference. So if you ever forget which organ is over to the right or to the left, I want you to know. You can refer back to this picture, but I'm going to start drawing the celiac trunk without these in the way because they do get in the way of our drawing. Now, I'll sometimes draw in a little outline of them, but most of the time I'm going to try to leave them off so that it's more easy to follow. So let's start. This is our diaphragm. And I've drawn its more 3D nature and drawn in the crus of the diaphragm, which are like two little legs. That's what crus means, through which the abdominal aorta comes from the thorax and enters into the abdomen. And now we're at about T12. And some people say that T12 is the level at which the celiac trunk branches. If you Google it, it's going to be anywhere between T12 and L1. But we're going to pretend for our sake that we are at T12 and we can see our celiac trunk coming off, and it would be deep to this lesser omentum, but that's not how we're going to draw it. So our celiac trunk, the first of our unpaired branches. Celiac trunk is what we call a trifurcation, meaning instead of bifurcating in two directions, we are going to trifurcate, which means we are going to branch in three directions. So we have three main branches off of our celiac trunk, the first of which is the simplest, so I'm going to talk about it first. And I always draw it kind of curling off and upwards and towards the left because this is our left gastric. So our three main branches include our left gastric, our splenic artery headed towards the spleen on the left side, and lastly, our common hepatic artery. So our common hepatic, splenic, and left gastric are the three arteries, main arteries of our celiac trunk. Now let's get into their branches. So at this point, I'm going to remind you that the esophageal portion of the esophagus that is in the abdomen is coming through the esophageal hiatus and then becoming the stomach. So this left gastric is very close to that area. So the left gastric is actually going to supply the upper portion of our lesser curvature of the stomach. So our left gastric will come off and then sort of loop here, which I realize is hard to see, so I'm going to start adding a black outline to these drawings. So our left gastric really loops because the stomach exists right here. So our lesser curvature to our duodenum, and this is where I go, well, I guess I lied, I'm drawing in the stomach. But you'll see why I'm drawing in the stomach. So we have an outline of the stomach there to help us. This is going to our lesser curvature, which means it's going to give branches off to that upper portion of our lesser curvature of the stomach to supply it. But just the upper portion. There's one more branch that comes off of our left gastric artery, and that is going to be the esophageal branches. So to that lower portion of the esophagus, we actually send up some branches to it from left gastric artery. So we have esophageal branches and left gastric branches to the lesser curvature of our stomach. That is left gastric in all of its branches. Now let's follow splenic. Now you've probably already noticed that splenic artery is going to go behind and deep to the stomachs. You wouldn't actually be able to see it unless you lifted up the stomach to look underneath it. That's where you're going to find splenic artery. The other really important feature of splenic artery is that it is classically very curly. So it is what they call tumultuous. It will quite literally curl like the tail of a pig sometimes. So splenic artery will head towards the spleen, obviously. Otherwise, why would we call it splenic? And it will branch into the spleen and provide it with blood, which is very important. But it will also give off two other important branches that we need to know. So the splenic artery will give off arteries called short gastrics that supply just the fundus of the stomach. So these are short gastric arteries off of splenic to the fundus of the stomach. So when you're short, think about being fun-sized. These short gastric arteries are fun-sized arteries, therefore they supply the fundus. Short gastrics, fundus of the stomach. Now, I said there were two branches off of splenic that we needed to know. The other branch is another gastric artery, but this gastric artery is going to supply the upper portion of the greater curvature of the stomach and is literally going to run in that greater omentum. This artery in the greater curvature of the stomach, running in the greater omentum, is called the stomach omentum artery. So it is literally called the gastro-omental or epiploic artery. Now, I just said a lot of words, so I want to explain them. Omental and epiploic mean the same thing. They refer to a fatty membrane. So an omentum and an epiploium are the same thing. So you can use either one, but the thing to remember is the lesser curvature always has gastric arteries. It's a smaller curve. There's less words in the name of the artery. Whereas the greater curvature has greater words, more words. So this is the gastro-omental artery. It is also on the left side. So we call it the left gastro-omental or epiploic artery, supplying the upper portion of the greater curvature of the stomach. That's left gastrix branches and splenix branches. So I'm going to mention it now because sometimes it comes up, although generally it doesn't. But I want to give you a full picture. Remember, the pancreas is actually behind the stomach as well, and the tail of it goes all the way to the spleen. It's a very long, skinny pancreas. They're so unexciting in lab, it's ridiculous. For something that does so much for your body, it's really crazy how they just don't look that interesting, to me at least. The pancreas, though, is going to get blood supply, many different branches from the splenic artery. So I just wanted to mention that. Splenic artery is also giving off various branches to the pancreas. So that exists, that is there. They are pancreatic arteries. If you have to learn them, they're pretty simple. They're just named kind of for how big they are and where they are. Okay, so that's really all the branches off of our splenic and our left gastric artery, which means we have one more branch that's going to have to supply all the other foregut structures. And it does quite well. This branch is our common hepatic branch. Now we know liver is hepatis, so this is definitely headed towards the right side where we find our liver, but it's common. And if you remember from before, other arteries and nerves named common something always become more specific. So we want to figure out, when does this common hepatic artery become properly directed towards the hepatis, the liver? So when does common hepatic become proper hepatic? And I'm going to tell you when. But first we're going to draw in the liver a little bit. And we're going to add in a gallbladder as well. So we have the liver and we have the gallbladder on the right side of the body. And we have this common hepatic artery. How you know it changes from common to proper hepatic is by looking for a branch that makes like a 90-degree angle turn inferiorly off of this common hepatic artery. There's going to be an artery that goes down like so. So, what is that artery? I like to refer to it as the goddamn artery because the first two letters are G and D. It's going to give off gastric branches and it's going to give off duodenal branches, so it is called the gastroduodenal artery. Call it the goddamn artery because if it changes from common hepatic to proper hepatic, that means all the things that are not the hepatis, branch-wise, are coming off of this goddamn gastroduodenal artery, which I actually love. I love this artery because it's very cool. But it heads down towards the duodenum, towards the pancreas head, and towards the gastric areas. So I will explain. So the GD artery tells me when we switch from common hepatic to being all about the hepatis which is proper hepatic. So gastroduodenal comes down. Now this artery is proper hepatic artery. Let's go through the branches of the gastroduodenal artery because it has some really important branches to us. It is going to be posterior to the duodenum. So it's actually behind it, even though it looks like it's in front of it. So just keep that in mind. But it's going to give off a very important branch to our stomach. That's going to be the gastric branch it gives off. Probably have an idea of what it is already because of where it is. So this artery from our gastroduodenal takes care of the part of the name that is gastric, and it's going to go to the greater curvature's inferior portion and anastomose with our left gastromental artery, which means this is, yes, our right gastromental artery. So we have a right one, we have a left one to supply the entire greater curvature. Just like the left one, we are running in the greater omentum. But it comes from gastroduodenal, which is a branch of common hepatic. So this is our right gastromental. Now I notice we are missing the continuation of our left gastric. Where does our right gastric come from? Well, I'm going to talk about it last because it is incredibly variable. So don't worry, we will complete that picture. Continuing though with the gastroduodenal artery, we're going to give off a duodenal branch to the duodenum, supply it. Not something we talk about too much, but I did want to fill that in. There are duodenal arteries coming off of the gastroduodenal artery, but more important than that, there's a very small, very important two arteries that are coming off of this gastroduodenal artery that have everything to do with the head of the pancreas. I'm actually going to take this little picture and pull it down here so we can examine some parts of this artery and talk about what's going on. So let's pretend we take the pancreas out and we can see our pancreas like this, right? There's our head of our pancreas, body and tail. Now, if I take that pancreas and I turn it 90 degrees away from you so that we are looking directly at the side, so the right side from the side. So we are looking, essentially, if I turn it, we'll just be looking at the head of the pancreas. So I'm going to erase this other part. So we are looking at the pancreas head from the side. The duodenum would be blocking our view if this was actually in the body. We're going to remove the duodenum so we can just see the pancreas head. I'm going to put PH for pancreas head. Now remember, we had the gastroduodenal artery coming down from above. And it gave off its duodenal branch and it gave off its right gastromental artery. And then it's giving off this other artery. Well, really two branches of another artery. Gastroduodenal artery is going to give off a branch that goes behind the pancreas head from above and a branch that goes in front of the pancreas head. So in anatomy, that's called anterior and posterior. And remember, we are very close to the pancreas and we are very close to the duodenum, and these branches are coming from above. So they are both what I would call superior. Superior, posterior, what? Pancreas duodenum artery. Pancreatico-duodenal artery. I'm going to put PD for short on the other side. So our gastroduodenal branch gives off a superior posterior pancreatico-duodenal artery that goes behind the pancreas head, and that also gives off a superior anterior pancreatico-duodenal artery that goes in front of the pancreas head. Now, that seems like kind of a lot of information for such a little thing, but the reason I'm bringing it up, and I'm going to leave this picture over here, is because this is an incredibly important two arteries. Why? Because your superior, posterior, and anterior pancreatico-duodenal arteries connect to inferior pancreatico-duodenal arteries that are from the superior mesenteric artery, which means these pancreatico-duodenal arteries are our anastomosis point between celiac trunk and superior mesenteric artery. really small branches, really long name, super important. So I'm going to box this off and leave it over here because we're going to connect these things at the very end to our SMA branches. But continuing on, we've given off our gastroduodenal. We've given off duodenal branches, we've given off our right gastroomental branch, and we've given off these posterior and anterior superior pancreaticoduodenal branches. Whew, such a mouthful. Okay, so we have to continue on with the proper hepatics. Proper hepatics will split into a right and a left proper hepatic artery. One goes towards the right lobe of the liver, anatomical right lobe, and then one goes to the left anatomical lobe. So this would be our left, and this would be our right. So this is our left proper hepatic artery and our right proper hepatic artery. Now, our right proper hepatic artery is very close to the gallbladder, and we still haven't talked about our right gastric artery. And here's why. The last two arteries that come off of our celiac trunk are really, really variable. And so their origin is incredibly variable. Where they begin is always a toss-up. So I'll put on the picture where they most commonly are, but the way you actually identify these arteries is to look for where they go. So the first one we'll address is that right gastric artery, which is going to supply the inferior portion of our lesser curvature. Now, it usually comes off somewhere between common hepatic and proper hepatic artery. There is no usual spot. It comes off, I would argue, wherever the hell it wants. So we're going to put it just in a neutral location coming off of common hepatic, but remember it sometimes comes off of proper hepatic or gastroduodenal even. So we got this artery supplying the rest of the curvature we did not supply yet. So that is our right gastric artery. Now, the truth about a right gastric artery is, I would say, and this is a made-up statistic, 90% of the time when you dissect, you're going to cut this artery. And it's not because you're bad at dissecting. It's because of the location of this artery and the omentum that it's going up inside of. So your left and right gastrics actually run in your lesser omentum. So when you remove your lesser omentum, if you weren't fully aware that that artery was there yet, this artery typically gets cut when you are taking the lesser omentum out. So it's not your fault. It's the fact that it's in the omentum and you didn't know it was there. That is our right gastric artery. So what's the other variable artery? Well, the other variable artery goes to the gallbladder, and it is called the cystic artery. If you think about the gallbladder itself and the biliary tree, what is the biliary tree? The biliary tree is essentially the ducts that hold and contain bile and transport it around. So there's our gallbladder, the body of our gallbladder. Our liver's up here, and our liver creates bile and then secretes that bile into hepatic ducts. So these are hepatic ducts on both sides. Left and right hepatic ducts that are for bile. So we're going to have bile coming in into a collective duct that is called the common hepatic duct. Hepatic is key. It's still just from the liver. Then that bile, if we're not eating a fatty meal, will actually enter this duct to be stored in the gallbladder temporarily. And this duct is called the cystic duct. So the gallbladder has a cystic duct that allows bile into the gallbladder, but also allows the gallbladder to secrete bile when we need it, like when we eat a fatty meal. So this is a two-way duct. Things can come in and things can come out. So let's say we ate a burger and we need some bile to break down those fats. We're going to then secrete bile through our cystic duct into our common bile duct. So we know that the cystic duct is a two-way duct, so it can allow bile in and it can secrete bile out into a duct that is no longer just from the liver, because we have stuff coming in from the gallbladder as well. So this is called the common bile duct. And the common bile duct will eventually meet up with the pancreatic duct to then secrete into the second portion of your duodenum through your major duodenal papilla. So the reason I bring up the biliary tree at all is to point out the word cystic, because the cystic duct connects gallbladder to the hepatic ducts, which become the common bile ducts. And the artery that supplies the gallbladder is named after this duct. So we call that artery the cystic artery. And it is also incredibly variable in origin. Most of the time it comes from our right proper hepatic artery, but sometimes it doesn't. And it really doesn't matter where it comes from. If you see an artery going to the gallbladder, it is the cystic artery. So that is our cystic artery coming off of wherever. Doesn't matter if it comes from splenic. If it goes to the gallbladder, it's the cystic artery. That's a really good rule for all of these arteries, because while this picture may look pretty, it doesn't look like this all the time. You really have to, when you're drawing this stuff out, look for the end goal of the artery and trace back. You can do that with every single one of these arteries if you make a mental map. And remember, you can just draw arrows to make this picture so that you learn this structure. Now, this picture is already kind of busy, but I am actually going to add more to it because I want to show you how these two anastomose with each other. And then we'll be taking superior mesenteric arteries branches in a different video and showing it. We need to get rid of all that celiac trunk stuff so we can actually visualize superior mesenteric artery. So I'm going to show you kind of the start of it. Well, superior mesenteric artery comes off very close to celiac trunk. They're actually really close together. But the way I drew this makes it impossible for me to show you the real relationship. So you do need to know that superior mesenteric artery has a relationship in proximity to the pancreas. So I'm actually going to draw it starting a little bit lower than it actually does. It's very hard to get to these arteries in dissection. They are so covered with all these different nerves. It's crazy. Very cool though. So this is our superior mesenteric arteries start, let's say. And what I actually want to focus on is just the very first branch that comes off of it. It's drawn a little wonky because my organs are out of place, but I'm going to show it to you so you understand the relationship. The very first branch that comes off of our superior mesenteric artery will always be an inferior pancreaticoduodenal artery that will then split into an anterior branch and a posterior branch. So let's bring that down to this one. From our superior mesenteric artery, which I'm just going to draw over here for the sake of clarity, not accuracy, superior mesenteric artery, SMA, is going to give off very first branch, and then it's going to continue and do other things, is going to be this inferior pancreaticoduodenal artery that has an anterior and a posterior branch. This creates the anastomosis, so this would be right inferior, inferior, posterior. They all have these little things attached to them, and I'm going to put PD for pancreaticoduodenal because I have no space. They're going to anastomose around the head of the pancreas, and the big concept I want you to take away from this is the anastomosis point where celiac trunk connects to superior mesenteric artery. Super important connection point. It's always going to be important to know where your large vessels connect and anastomose, which means connect and provide collateral supply to one another. So we're going to also see later how the SMA connects to the IMA and really completes the entire digestion picture artery-wise. So that's where we're going to stop for celiac trunk. We'll pick it up with SMA next time.
As always, thanks for watching. Don't forget to like, share, and subscribe. The next video will cover the SMA and the IMA in more detail. Toodles!